We've updated our sensitivity analysis to generate results at 3 different values for the initial concentration, and we've put that in a list we call results. Well, that means we've broken our code for generating the graph because before our results only had one result in it for one initial concentration, and now we've got 3. So our code no longer works. We need to fix that. We are still saving the results that we generated as a list as an object in an R data file with the save RDS. And if we go back to our product script that is generating the graph, we're still loading those results. But now these results are going to be a list of 3 different results as opposed to just one set of results. So what do we need to do in order to make this script work? Well, ultimately, I'm going to double click on results here and highlight results, and that shows me in RStudio where results occurs in other places. You can see that box around anywhere it finds the word results. You can see we're not really using those results anywhere. All of this code is just setting up our plot. We don't really use the results for anywhere except where we're putting points on the graph. Well, that kind of makes it clear why I like to break down making graphs this way sometimes, is I made it very easy on myself to think iteratively about how many points I put on this graph. In this case, I can put a loop around this points such that I can plot the results for each of the 3 different results that I have for different initial concentrations. So if I add some lines of code around this, I can do a for loop. And as before, I want to think about an index. I'm incrementing an index going from 1 to whatever the length of this results list is that I've read in. I'm going to open curly bracket to start the block of code that I'm looping through. I'm going to indent the code so it's really clear where my loop starts and stops. And here in points, instead of going directly to an element called times of results, I now have to index the results. I have to talk about which results I want to plot the times for and which results I want to plot the concentrations for. So again, I'm going to need the double square bracket indexing for the list because I want the contents of a given result from the results list. And I can use this const index to say which one that I want. It's going to be the same deal for my other results. And note, my code is getting a little wide here. I'm going beyond my 80 character limit. So I'm going to go ahead and break this into several lines of code. So there's 1 argument per line. So here I'm starting my call to points. I have 3 arguments, the X argument, the Y argument, and the PCH argument. And then I put my close paren here and I tab it over so that it's at the same level of points. So it makes it very clear where my start and stop to my call to the points function is. So now, if we think about how a loop works, the first time through the loop, the value of this index is going to be 1. That means I'm going to be grabbing my results from the first result element in my results list. The second time, this index is going to be 2. So I'll be going to the second element of my results. And the last time it'll be 3. So I'm calling points 3 times and I'm putting those points on the graph. Let's go ahead and see what happens if I run this script. And I need to go to my product folder and bring up this visualization. Opened up on my other screen. I'll bring it over here. Now we can see we have 3 different plots for the 3 different initial concentrations. Now there's 2 things about this plot that we could probably make a little bit clear. First of all, we're using the same symbols for all 3 plots. Well, ultimately, that's a little bit misleading. If we want to represent these plots as being from 3 different model runs, we probably want to use different symbols for those model runs. Also, you can see that for our higher initial concentration, we have data that's going off the top of our graph. So we don't have the right coordinate system for our axes to allow us to see all the data for these runs. So these are things that we can go back to the code to address. First, let's address our scaling. You recall our original script put in set numbers for the x-lim and the y-lim, where we want to set the coordinate system for our graph. Now we could go ahead and put in different numbers, but this is what's called hard coding. That means we're putting numbers in specifically when really we could make our program a little more flexible in terms of figuring out what these numbers are on its own, rather than us having to tell it specifically how big this graph is. Now we have all of our results in a file, and we can look at those results to figure out what our minimum values and our maximum values are for both our x and our y axis. And again, we can use a loop in order to extract information from the results to figure out what the limits of the y and the x axis should be based on the data that's in the results. So to do that, I'm going to do a loop. First of all, I need to set up the initial values for my x-lim and my y-lim that I'm going to run through my loop and say, can I find values that are larger or smaller in order to set the right minimum and maximum values? So initially, I'm going to set the minimum value to infinity and the maximum value to minus infinity. And that's just because I'm going to say, well, I'm certainly going to find a value that's less than infinity. So these are just placeholders for my first time through the loop, and you'll see how this works in just a second. Likewise, there's going to be values greater than minus infinity for my maximum value. And we'll see how this works in just a little bit. I can do the same initialization for my y-lim. Now I have some initial values that I can compare to the values in my results data structure in order to come up with the minimum and the maximum. And I want to do that not with just one set of results, but all three set of results. So here I need to go through all of my results again, and I can again do that with a for loop. Now in this case, for this particular purpose, I don't actually need an index. I'm not going to be indexing anything. I just need to go through each of the elements of my results. So I can do another type of for loop here in R that is not based on an index, but simply goes through each element of the list that's called results. So if I say for each result in results, I can put my open curly bracket, and I'm going to repeat some code within this loop in order to figure out what my x-lim and y-lim values are for my plot window statement. Okay, so what do I do in this loop? I need to figure out if there are values smaller than infinity for x-lim, the minimum, and greater than minus infinity for x-lim, the maximum, and I need to do the same thing for the y-lim. So I can do that one at a time. The x-lim minimum, or the first element of x-lim, I'm going to use single square brackets to talk about just this INF, this first element. And I'm going to say that needs to take on the minimum value of some set of values. And I'm going to use the min function to define that. The first value I want to put in here is the original x-lim value, because I'm going to be going through this loop multiple times, and I'm going to assess this based on what my current x-lim minimum value is from the last time through the loop. Now, if it's the first time through the loop, that x-lim 1 is going to be infinity. But after I go through the loop, that x-lim is going to be something else based on whatever the minimum was from the first time through the loop. Then each time through the loop, I want to look at my result, and I want to look at the times. Remember, we're plotting time on the x-axis, so my x-min is going to be related to my minimum time. Now, in terms of the min function for R, there's another argument called na.rm, and this is where you tell it whether you want it to ignore NAs or not. Now, in this particular analysis, we're not sure when or where we're going to have NAs. Well, actually, we'll have NAs for our Y values in some cases if we're dealing with our filtered data. So just to be sure that we don't think about NAs when we're coming up with this min and the maximum, we're going to tell to remove NAs when it does this analysis. So this is just telling it, don't consider the NAs when you're coming up with a min or a max value. Just ignore the NAs. And that's suitable for what we're trying to do. So this is just to make sure that we don't accidentally break our code if we have an NA floating around. Now we want to do the exact same thing for the maximum for the xlim. So that means we just need to change these to a 2 and change this to a max. So the first time through this loop, the xlim second index is going to be minus infinity, and it will compare that to the results of the time to figure out what's the maximum time. So if we have a value for the maximum value for time for results is going to be something that's greater than minus infinity. So the first time through the loop, this xlim2 will become something other than minus infinity based on whatever that first list element has in it for time. And then the second time through the loop, it's going to start with this new xlim1 and xlim2 and figure out if there's a smaller or larger value for xlim1 or xlim2 respectively based on the time, the third time through the loop. So it's going to sequentially change these xlim1 and xlim2 based on whether there's a smaller or a larger value for a time in the results $time element of the result. So we can do the same thing then with our ylim. So I'm just going to cut and paste this code to get started. And there's a ylim1 that's going to be the min of ylim1. But for the y-axis, we're not using time. For the y-axis, we're using our concentrations. I'm going to double check. Is it called concentrations? Results? Yes, CONSCS. So for now, we're plotting concentrations. So we want to compare our ylim1, which the first time through is going to be infinity, and see if there is a smaller value between our original ylim1 and whatever's in the results concentration for our current result. And finally, we can do the same thing for our max for our ylim. And just need to change these indices to a 2 instead of a 1. So in this case, when we're going through the loop, we're not using an index this time. We're just getting a specific result from the list of 3 results that we know is there based on our analysis, and that we can confirm that here. We see a list of 3, and it's going to be for 25 as our initial concentration, 50 for the second element, and 100 for our initial concentration for the third element. And each time through this loop, our result will be one of the elements of this list. And we can pull from that list, from each element, the time and the concentrations to compare with our minimum or maximum values from the last time through the loop. Ultimately, when we come out of this loop, we're going to have the minimum value for all of the x's in the xlim1 element. We're going to have the maximum value across all of the x's or all of the times in our xlim2. Likewise, we'll have the minimum value for all of the concentrations across all 3 elements in ylim1 and the maximum value in ylim2. Then we just need to stop hard coding this plot window where we put our xlim that we calculated from this loop and our ylim that we calculated from this loop. So hopefully, if I don't have any bugs here, I can rerun this. And if this all worked right, my axes should be scaled so that I see all 3 plots. I'm going to bring this up, and it automatically refreshed. And yes, you can see it has now rescaled this y-axis such that it goes from 0 to 100 now, which is our maximum value across all of our concentrations. And we have the right scale on our axes to see all 3 graphs. Now let's figure out how to make each of these plots for the different initial concentrations use a different symbol in our graph. I'm going to go back to our R code, and you can see under points, our call to points for making each of these plots, we have hard-coded the value 2 for the PCH argument. And that means we are specifically selecting the number 2, which represents these triangles. Now you can look up what PCH values give different symbols, but there's one way you can get R to quickly plot that for you. And I could do a plot where my values for x, and you can just give it x values. If you do that, it's actually going to assume that's what you want to plot on the y-axis. That's a little bit confusing, but if I want to repeat the number 0 26 times, I'm doing that because I know there are a total of 26 symbols available that are numbered from 0 to 25. So this is going to plot at the same y value 0, a different symbol for 26 different symbols. And if I don't give it a y argument, it's going to assume that on my x-axis, it's going to be numbered 1 through 26. And you'll see what I mean in just a minute. I know that's kind of confusing, but it's the way that R interprets it when you only give it this first argument, this x argument. And then I can give it PCH values going from 0 to 25. So again, this is going to create a vector of integer values from 0 to 25, and it's a total of 26 values, such that each one of these points that it's plotting, it's repeating from 0 to 26, is going to have a different point to it based on this vector of PCH values that I'm getting it. So if I run that line of code, it's going to pop up. Again, I'm using the default device here, so it's just going to pop up in RStudio. You can see that it plots a bunch of different points, 26 of them to be specific, starting with a square, a circle, and a triangle. And it plots them versus just integer values for x, because I didn't give it x values. I mean, I gave it an x argument, but that's not the same thing necessarily as x values. And it's just assuming it's starting at 1 and numbering those to 26. So to get the point value from each of these, you just find the symbol you want. In this case, we're starting with a triangle, right? You figure out where you are on the x-axis. In this case, that's 3, and you subtract 1. And that's why a triangle is 2. So 0, 1, 2. So with this in mind, we can just use integer to represent different points. And then we can use that to our advantage to select however many different point styles we need based on the number of graphs we need to make. That's really what I'm getting at with all of this. So if we're going to do that, that means up at the top of our script, right after we've read in our data, we can tell it, we can have R figure out what are the different points we need in order to make a graph from this particular results. And we can say that our PCH vector, we're going to create a vector of PCH values, so I'll call it PCHs, is going to be 1 to the length of our results that we've read in. Remember, there are 3 different results based on 3 different initial concentrations. So the length of results is going to be 3 in this case, but we've not hard-coded that. This is going to be however many values for PCHs that we need based on however long results are. And we're going to start at 1, and that means we're going to start at the circle and go to the triangle and then go to the plus sign, because 1 is this circle, 2 is a triangle, and 3 is the plus sign. So we're basically creating a vector of integers representing these 3 symbols that it's going to use for the 3 results that come back from our analysis. Now that we've created this PCHs, we don't want to hard code this PCH equals 2 anymore. We want to tell it PCH, and here's where we're going to use our const index. So this PCH is going to be however big it needs to be for each one of the results. So we know we have as many PCH values as we do elements in results. And then each time through, we're going to go, the first time through this loop, the value is 1. So the PCH we're going to have is the first element of the PCHs. Oops, sorry, this should be PCHs. PCHs matching what we created up here. The first element of PCHs, the second time through loop, it'll be the second element. That should be the triangle. The third time, it'll be the third element. That'll be the plus sign. So let's see if that works. I'm going to run this again. I'm going to bring back up, and it's automatically refreshed because I'm using this Sumatra viewer that automatically refreshes the PDF. And indeed, you can see the first element, which was the the 25, the element with the initial concentration of 25 is circles. The second element where the initial concentration was 50 is the triangles. And the third element where the initial concentration was 100 are the plus signs. So now we have 3 different symbols for our 3 different plots. And this is starting to look more and more like a professional representation of the results of this analysis.